In this video, I want to talk about what the trigonometric ratios are. In the last video, I talked about sine, cosine, tangent, and the abbreviations, but I didn't say what they are. So that's what I'm going to work on in this one. Now, here's my right triangle, and I've written a little a under the 7. I'm going to call side BC, which I know equals 7. I'm going to call it little a. Now, I want you to pay attention here because I have a capital A in the problem, that's the angle, and I have a lowercase a for the side. And in a math problem, if you see a capital A and you see a lowercase a, they are completely different from each other. And in this video, capital A is the angle, lowercase a is the length of the side from B to C or C to B. You could reverse them and it's the same side. I'm going to use lowercase b for side that's 5. I'm going to write my b as a script b because if I write a print b, it's going to look like a 6. And for the hypotenuse, I'm going to use C. Now, something you might not have realized is the way I've labeled it is the conventional way to label a triangle. If I'm using the lowercase letters for the sides, I'm going to use a lowercase a for the side that is opposite from angle A. I'm going to use a lowercase b for the side that is opposite from angle B. And I used a lowercase c for the side that is opposite from angle C. Generally, this is how we'll label our triangle. Now, because this is a right triangle, I can use the Pythagorean Theorem to find side C. And the Pythagorean Theorem, if you have a right triangle, then one of the legs squared plus the other leg squared equals the hypotenuse squared. With the labeling I have on this picture, it's a squared plus b squared equals c squared. For the a, we'll plug in 7, 7 squared. For the b, we'll plug in 5, 5 squared equals c squared. Let's work it out. 7 squared is 49. 5 squared is 25. 49 plus 25 equals c squared. Let's see. 40 plus 20 is 60. 9 plus 5 is 14. So 60 plus 14, 74. 74 equals c squared. Well, c is the square root of 74. You could put that in your calculator and get the decimal, but the more and more math you do, the more and more you would say, you know, I think I'd just like to leave it as the square root of 74. And that's how I'm going to leave it in this video. Now, what are the trig ratios? Sine, cosine, and tangent. And the way it works, the sine of angle, you have to have an angle for each of the trig functions. I'm going to do sine parentheses angle equals, the sine is opposite over hypotenuse. I could abbreviate that O over H. Now that's not 0, that is the letter O. Maybe I want to write OPP, HYP, so that I don't confuse that opposite with the number 0. The cosine, I went ahead and I wrote out the whole thing. Cosine of an angle equals, I'll abbreviate it this time, cosine of angle. The cosine is adjacent over hypotenuse. And then we have tangent. So the tangent, went ahead and wrote out the word tangent of an angle. The abbreviation is TAN of the angle. Tangent is opposite over adjacent. Now, if you remember when I did the video with opposite and adjacent, the opposite and the adjacent will change depending on what angle you're looking at. Let me separate this because they look like they're all kind of running together right there. As I look at my picture that's up here, I'm going to do the sine, the cosine, and the tangent. Now we'll do those from angles A and angles B. The sine, I'll just write SIN, parentheses A. You have to give the angle so we know what one you're looking at. That is opposite over hypotenuse, but it's the opposite side from A. So, have to look at A. So, okay, if I come through the triangle, I get to side 7. So, the sine of A is 7 over the hypotenuse, which is the square root of 74. And I'm just going to leave it that way, square root of 74. The cosine of A, cosine is adjacent, I'll write ADJ over hypotenuse. And as I look at my picture, adjacent to A is side B. That has a length of 5. So cosine of A is 5 over the square root of 74. And then the tangent of A is opposite over adjacent. Now the side opposite from A is 7. So that's 7 over adjacent to A is 5. Now if I switch it up and I look at angle B, my adjacent and my opposite have now traded places. So if I want to do the sine of angle B, the sine is always opposite over hypotenuse. The side opposite from B is going to be 5. And the hypotenuse is always the one that's across from the right angle. So hypotenuse in this case is always the square root of 74. The cosine of B is always going to be adjacent over hypotenuse. But because I've switched angles, the adjacent side is different. The one next to B is the leg that's 7. So cosine of B is 7 over the square root of 74. And then I'll do the tangent of B. Tangent is always opposite over adjacent. As I look at B, and I can go across, I get 5. 5 adjacent is 7. So the tangent of B is 5/7. So sometimes students may want to try to say, I'll just memorize the formulas. But you really can't memorize a formula here because the opposite and the adjacent sides are trading places when you switch angles. So your best bet is to remember, some people will do SOHCAHTOA, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And you can kind of split it up like that. SOHCAHTOA. A lot of people remember it that way. You can come up with a phrase that helps you remember it. I know I saw one on the video I watched earlier, but here's one a lot of people will remember. Some old hippie caught another hippie tripping on acid. If you come up with something different, that's great, but that's a pretty common one that people will kind of say.